Right, on the back are some more examples that say simplifying expressions with rational exponents. So there's some directions up here at the top. First of all, it tells you to rewrite all the radicals in exponential form. So we're going to take the radicals and write them as exponentials if we have radicals to start with. Then we use our exponent rules to simplify. We went over exponent rules in the first two videos for today. And then you write your answer as a radical in simplest form and rationalize if we need to. So we're going to use our exponent rules a lot here from the first two videos from today. So we haven't really used them yet, but we're going to start using them again right now. So I have here x to the 1/3 times x to the 4/3, right? So this is base to a power times base to a power. When it's base to a power times base to a power, the rule says that you add the exponents together. So this is going to say this equals x to the 1/3 plus 4/3. Okay, x to the 1/3 plus 4/3. Well, the two numbers already have a common denominator, so that's good. So that means this is x to the 1 plus 4 is 5/3. And when I go write that as a radical in simplest form, because my step number 3 says to go back and write these answers as radicals in simplest form, the number on the bottom is my root. So this is the cube root, and it's just x to the 5th by itself, so I can write it like this. If you want to put the cube root of x in parentheses and put your 5 on the outside, that's fine also. Okay, p to the 1/4 times p to the 3/2. Base to a power times base to a power. They're the same base. They're both p's. So when it's base to a power times base to a power, we add the exponents. So I have p to the 1/4 plus 3/2. Now, these do not have common denominators. I need to get them real quick so that they do have a common denominator. So, or if you want to, you can just add these two fractions in your calculator. Your calculators will add fractions and give you a fraction answer. If you don't know how to do that, then that's something you can come up and ask me in class, or if you're on the Google Meet, unmute and ask me if you want your calculator to be able to do that. I think it's just as easy to get him to have a common denominator of 4. This one, in order for this to be a 4, it needs to be multiplied by 2. So I'm just going to multiply this whole thing by 2. And when I do that, I get p to the 1/4 plus 6/4, which is p to the 1 plus 6 now is 7/4. So I have the 4th root of p to the 7th. The number on the bottom is your root that comes on the outside. Okay, now I have division. Okay, so this is my quotient rule from our exponent rules that we did on the first video. This is m to the 5/2 divided by m to the 7/4. Remember, this means division. These were multiplication. You add exponents. This is division. You subtract exponents. So this is m to the 5/2 minus 7/4. And again, I need to get a common denominator to be able to subtract these guys real quick. You subtract the exponents. This one just needs to be multiplied by 2 on the top and bottom. So that will give me m to the 10/4 minus 7/4, which is m to the, 10 minus 7 is 3/4. So I'm down to m to the 3/4. And when I put that back into radical notation, that is the 4th root of m to the 3rd. Okay. A to the 1/3 to the 5/2. Okay, I have one base to a power to a power. So when you have one base raised to two exponents, that's the power rule, and that's when you multiply. So here, when it was multiplication, when it was base to a power, you add. Base to a power, you add. I have two bases here. Base to a power divided by base to a power, you subtract. This is one base to a power, you add. Multiply. So A to the 1/3 times 5/2 is A to the 1 times 5 is 5, 3 times 2 is 6, A to the 5/6. And if I go write that in my radical notation, the 6 is my root. So this is the 6th root of a to the 5th. Again, this one is base to a power to a power. Base to a power to a power. So I have 32 to the 1/2 to the 1/2. So that means I multiply these two exponents together. So 32 to the 1 times 1, well, I'll go ahead and write it out. 1/2 times 1/2 is 32 to the 1 times 1 is 1. 2 times 2 is 4. That is the 4th root of 32. Now I'm going to check my calculator real quick and see if the 4th root of 32 is a nice number or if it's a decimal. So your calculator does roots. Desmos does all kinds of fun roots. So in your calculator, if you guys don't know where this is, if you go under math and you go to down to number 5, it says x root. So that's how you can do any other root in the world. 4th root, 5th root, 20th root, it doesn't matter. But you have to put the root in the front, okay? So if I'm going to find the 4th root of 32, I need to go, I got to get out of here, and I got to hit the 4 to do my 4th root. Go back under math and go down to that number 5. That's going to do the 4th root of 32. And I can see that that's a decimal, and so I don't want to use it. So I'm just going to leave the 4th root of 32. It's a much prettier number. Okay? And then I've got 8x squared to the 2/3. So this one I have to be really careful with because the 2/3 needs to go to the 8 and to the x squared. So I have to be careful here. And I'm going to kind of distribute that 2/3 into the parentheses so that I can make sure I get all of my simplification done right. So this is going to say 8 to the 2/3 and then x to the 2 times 2/3. All right, so I'm going to keep going across here with some simplifying. 8 to the 2/3, that means I'm going to do the cube root of 8 squared, and then it's times x to the, this is base to a power, so 2 times 2 is 4, and this 2 I can put it over 1 so that I have two fractions here, and 1 times 3 is 3. So I'm going to keep doing some simplifying here. I'm going to keep coming across. The cube root of 8, I know that's 2. So 2 times 2 is 4, times 2 is 8. So this cube root of 8 part simplifies down to just 2. All right, so I'm going to do that. 2 squared times x to the 4/3. And now I'm going to write it with radical notation. So 2 squared I can do. Okay, again, this 2 came from the cube root of 8, but I still have this squared out here on the outside. So this is going to say 4, and then I'm going to turn this into radical notation. Cube roots x to the 4th. And I got the 4 from taking 2 squared.